This is select answers for SP53, number 2, 6, 8, and 13. In number 2, we're given information about x-intercepts, x equals -8, x equals 1, vertical asymptotes at x equals -2, horizontal asymptote at y equals 0, and a hole at 6. To take care of the x-intercepts, we need that in our numerator. That's what will give a y value of 0. And to take care of our vertical asymptote, we for sure need some type of factor of x plus 2. I'm going to look at the horizontal asymptote last. I sometimes find that easiest because we have to look at the degrees. And it's easy to see at the end what degrees we have. And then we've got a hole at x equals 6. Remember that holes have a factor on the top with a factor on the bottom. So now I'm going to take care of the horizontal asymptote part. I know it has a horizontal asymptote at y equals 0. That's the case where you have p of x less than q of x in reference to the degrees. So right now, let's see, the degree on this is 1. Degree on the top 3 is 1, so right now I've got a degree of 3 on the top and I've got a degree of just 2 on the bottom. So I'm going to need the bottom to actually have a higher degree. And to make sure that I don't change any of the information, I'm going to put it on the x plus 2 part. Then I know that I still have all the requirements. I still have the vertical asymptote at x equals -2. Now I have a horizontal asymptote at y equals 0. The degree on the top is 3. The degree on the bottom is 4. And I've got a hole at x equals 6. In number 6, we have to write an equation. I'd always start by finding your horizontal and vertical asymptotes. It looks like we've got vertical at x equal 2, horizontal at y equals 4. So I know I'm going to use that in my equation. So for the vertical asymptote, I'll have to have an x minus 2. Again, like mentioned in the previous problem, I would save worrying about your horizontal asymptote until the end. I also have to make sure I take into account zeros. So I'm going to need that x minus 6 on the top. And now lastly, I checked the degrees. The degrees on both are equal. I got a degree of 1 in here, degree of 1 in here. So this possibly could be the graph. I'm good with that. With the degrees will give me a horizontal asymptote. To make it a horizontal asymptote, to get the leading coefficient of 4, that's what I need. I need leading coefficient of 4 over 1. What you can do is you just put a 4 in front here. Then when you distribute, you have a 4x over x, and that would give you your horizontal asymptote. After that, you can always graph it on Desmos or your graphing calculator to see if it fits the shape. In number 8, I look for the same information. Looks like there is a vertical asymptote at x equal to 1. And then looks like there's a horizontal asymptote at y equals 4. And I take care of the vertical asymptote by putting that on the bottom. Now I also have to take care of this hole. Remember, holes will have the same factor on top and bottom. They're still undefined values, just like asymptotes. And then lastly, take care of my x-intercept. Make sure you have that on the top. And last, I look at my horizontal asymptote. I've got the degree is the same. Degree on the top is 2. They're both 2, so I'm okay with the degree situation, so I know I have a horizontal asymptote. So to make sure I get the correct leading coefficient, I'm just going to put a 4 in front here. Then if you were to distribute everything out, distribute, blah, 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 you'd still end up with 4 over 1. Okay? And then, of course, again, you can always check on Desmos, check on your graphing calculator, and make sure that the equation looks like the graph. In this one, you had to decide if you're going to put 1, 2, or 3 on the exponents of each binomial. So let's look at the vertical asymptote of x equals -4 to start. I want to look at the shape that it takes on around that asymptote. It takes on this shape, and that gives me an even multiplicity. So I know it's got to be a 2 on the x plus 4. And then next, same thing, look at your 1. Takes the same shape around the asymptote, so it's going to have a 2 as well. And then next, I look at my x-intercepts. At this x-intercept, I've got a parabola shape. Parabola shape would give you an even exponent. So I've got a parabola shape at x equals -2. That's the shape it takes on at the zeros. And then this one, you can do a couple different things. You can guess and check. You could put 1 in, you could put 3 in and see if it makes sense. But what I would look for next is to look at what your horizontal asymptote is going. There's no end behavior that's the same here. This one looks like it could even out, but this one is not approaching the same line. They'd have to approach the same line for it to have a horizontal asymptote. So this is a none situation, which means that my degree of p of x should be greater than my degree of q of x. So right now the degree is 2 plus 1 is 3. This one is 4. So I know this one can't be 1 anymore. The degree on this can't be 1. It's going to have to be a 3. And now I've got a degree of 5 on the top, degree of 4 on the bottom, so I know that it satisfies the rule for the horizontal asymptote. In number 12, I'm going to do the same process. I'm going to look and see what shape it takes on around the asymptotes. So this one at x equals -4 coming that direction, going that direction, that gives me an odd multiplicity. I'm going to try 1 to start. Yes, it could be 3, but I'd always start with 1 and see what happens. And then the next one is the same idea, takes on an odd shape around the asymptote, so I'm again going to try 1. And then I look at the shapes it takes on at my roots. So at -3, this line is slightly less curvy than this one. So my guess would be that this one takes on an odd shape of 1. And now again, you can use a clue that your horizontal asymptote will give you. In this case, there's no horizontal asymptote. This one's not really approaching anything, and this one's going to go off into infinity. So this is a none situation. So again, we should have our degree of p of x greater than our degree of q of x. And right now, if I leave the x plus 2 as a 1, it's not going to happen. 1 plus 1 is 2, and 2 on the bottom. So my bet would be that this is an S shape. My bet would be that this is a cubed, and then that would satisfy all the requirements. Again, you can double check after your graph, but if you can narrow down a cubed or 1 and use your best judgment, then you can double check on a graph.